Well, dear students, here I am going to solve some question, simple question for you for practice purpose. Here is a question: if stress of 1 kg per millimeter square, stress equal to 1 kg per millimeter square, is applied on a wire of steel. This stress of 1 kg per millimeter square is applied if y equal to any wire, y equal to 1 into 10 to the power 11 Newton per meter square. Then calculate percentage increase in the length. Stress 1 kg per millimeter square. So what is the percentage length? So you know y equal to f into capital L upon a into small l, or small l upon n equal to f upon a into y. So f upon a equal to stress upon y. So you are asked here to find percentage increase length. Means you are asked here L upon L into 100%. So here stress is 1 kg. So stress 1 kg per millimeter square. Convert into 1 into 9.8 Newton millimeter square. How many is 2 millimeter square? 10 to the power minus 6. So it is 9.8 into 10 to the power 6 stress. Put this value here. 9.8 into 10 to the power 6 upon 1.0 into 10 to the power 11. So it is left only 9.8 into 10 to the power minus 5. So L upon L into 100, then it will become percent. So 9.8 into 10 to the power minus 5 into 100 percent. It is 9.8 10 to the power minus 3 percent, means 0.0098%. So just for sake of practice, I have given you this question here. Now next question there. Question was the stress of this is applied across wire of young model this. Find percentage increase in length. So it's simple question here. Now come to next question. Actually I am introducing how to solve problems. Nothing else. I will do some concept question later on. The area of cross section of wire of length. The area of cross section of wire is 0.5 millimeter square. Area 0.5 millimeter square. Length is equal to 4 meter. Length of wire is 4 meter. How much work is done? How much work will be done in increasing length by 1 millimeter? 1 millimeter increase करनी है length, small l increase length, and y for this young modulus is given by 2 into 10 to the power 11 Newton per meter square. I am reading question again. The area of cross section of length of wire, the area of cross section and length of wire are 5.5 millimeter square and 4 meter respectively. How much work will be done to increase the length by 1 millimeter? Young's modulus of elasticity is this. While deriving elastic potential energy of material, that work done, actually I proved that half stress into strain into A into L. Cross area into length. And you know, stress upon strain. Strain upon strain equal to Y. So stress is equal to Y into strain. To put this value here, W is equal to half. I mean Y into strain and into strain square into A into L. Put the value here 1 by 2 into 2 into 10 to the power 11 strain. Length increased by strain, actually you know, is equal to increase in length upon original length. So 1 millimeter means 10 to the power minus 3 meter upon L 4 square into area of section 0.5 millimeter square. This meter square 1 millimeter, sorry, 1 millimeter square is equal to 10 to the power minus 6 meter square into 4 into length 4. So you have to solve this very easily. This 4, then it is 10 to the power 11 into 10 to the power minus 6 upon 16 into 0.5 into 4 into 10 to the power minus 6. So 4 is 16. So it is 0.5. 0.5 into 4 into 12 और ये 11 कितना बचा -1 10 to the power -1 or you can write 5 into 10 to the power -2 joule 1.25 you can solve it है ना. This is about 1.25 10 to the power -2 joule. This is about done. So I hope you have got it the problem. Now I come to next question here. The pressure of fluid having volume V equal to 3 into 10 to the power minus 3 meter cube. The pressure on liquid having volume, this is increased delta P increased by 6 into 10 to the power 6 Newton per meter square. The volume of fluid is diminished by delta V equal to 5.0 into 10 to the power minus 7 meter cube. Find bulk modulus. What is B? This is a simple question here. You can do. Actually, P is equal to minus delta P upon delta V into V. So delta P simple minus 6 into 10 to the power 6 into delta V 3 into 10 to the power minus 3 upon this decrease in volume. So V should be minus. So minus 5.0 into 10 to the power minus 7. So how much it will come? Minus plus 3 is 18 upon 5 into 10 power minus 7 or plus 7 plus 6 13 to 10. So it is 5 3 are 15, 3.6 times the power 10 Pascal or Newton per meter square. This is the answer here. Now I come to some good questions which are asked in competitive exam or entrance test. I am coming to them. He says here, one end of horizontal thick copper wire of length 2L, radius 2R. Copper wire here, length 2L. 2L length, radius this 2R. Is welded here. Welded to and another horizontal copper wire of length L. Its length is L and area R. When arrangement is stretched by applying forces at two ends, the ratio of elongation in thin wire to thick wire. Actually, we have to apply equal force on both sides. These two forces equal. So you are asked ratio of L, suppose this length is L, 12 here. So here let it be L upon L, and here it will be, let it be L1 it is L2, L2 upon 2L. So this upon this क्या होगा? You are asked here. When the arrangement is stretched by applying forces on at two ends, the ratio of elongation, L2 upon L1 if L2 is the increased length this and L1 is this. So you know both the wire of copper. So they say they have same young modulus, and y equal to F into L upon A into L. So for first wire we take F, the same force F into 2L upon A, pi r square, pi into 2 pi r square, pi into 2 r. Actually we need area of construction, that is A equal to pi r square. So pi r 2r is whole square is equal to F into, this is L here, for this. Sorry, L1 or into pi into r square or into L2. F cancel, L cancel, here pi cancel, r square cancel. So 2 upon 4 L1 is equal to 1 upon L2. One by 2. So L2 is equal to 2L1. So L2 upon L1 is equal to 2. Simple answer. So that way we get the answer as 2. It is 2 here. I hope we have got the question. Two copper wire, one of length 2L, radius 2R, other of length L and the radius R, are stretched by equal forces on both sides. The ratio of elongation of shorter length wire to longer is what? ये कुछ आपसे. So this can be done by this way. Now next question here. Here next question there. Two wires made up of same material have same volume. Two wires are made of same material have same volume. However, wire 1 has cross-section area A and wire has area 3. Wire 2 has cross-section area 3. If the wire 1 increase, if the length of wire 1, if the length of wire 1 is increased by delta x on applying force F, how much force is needed to stretch wire 2 by same amount? So there are two wires of same material. However, wire has cross-section area A and wire has 2. They have same volume. By wire 1 and wire 2, they have same volume. Volume V or volume here V. And you are told wire, however, wire 1 has cross-section area A, its area A and area 3A. 3A. If length of wire 1 increased by delta x by application force, then what will delta x, x1 and x2? So how much force is required to, some force F1 required for increase delta x, so how much force F dash is required to elongate this wire by same distance? By how much force is required? How much force is required needed or required to stretch wire 2 by same amount? Elongation सेम होना है. अगर यहाँ फोर्स है लगा तो ये एवरेज कितना होगा? They have equal volume. I told you many times volume is equal to area of cross section into length. Volume होता है. They have same volume. Its area is A is 3A. So A into L is equal to 3A into L dash. है भाई? 3A into L dash. So it means L is equal to 3L dash. यानी कि ये तार लंबा है. ठीक है भाई? अब we know y equal to f into l upon a into delta, वो delta x कहा है यहाँ. तो f is equal to y a delta x upon f is equal to y upon l. तो यहाँ पर एरिया A है और लेंथ L है. And this force required here, equation 1. How much force required here? That F dash equal to y into area 3A or L dash L by 3. L by 3. ठीक है भाई? तो इट इज 9 into y a delta x upon L. And this is F here, y a delta x upon L. So it is 9F dash. So here force required is 9 times. हाँ भाई 9 times 9F. F dash equal to 9F. So these are some questions which change your understanding. So please repeat these questions yourself I have dictated a question. It is not possible for me to write here. When I tell the question, you note the data and make the note of that. Thank you.